Imagine stepping into a world where every plant glows with life, majestic floating mountains defy gravity, and an entire species shares a literal neural connection with nature. Welcome to Pandora, the breathtaking, vibrant world of James Cameron's Avatar. Today on The Science Enthusiast, we're diving into the science behind the magic of Pandora to uncover how much of it is rooted in real-world possibilities and how far it stretches the imagination.
Dana! No! Atokirina! Atokirina.
Let's begin with one of the most mesmerizing aspects of Pandora, its glowing bioluminescent ecosystem. From the forest to the creatures, almost everything on Pandora emits light in the dark. Bioluminescence isn't just a stunning visual effect, it's also a real phenomenon right here on Earth. Take fireflies for example. They produce light through a chemical reaction called bioluminescence, which involves the enzymes luciferase acting on a compound called luciferin. The reaction releases energy as light, also used for communication, attracting mates or deferring predators. Similarly, deep-sea creatures like anglerfish and certain jellyfish use bioluminescence to survive in the pitch-dark depths of the ocean. Could a planet like Pandora, with its diverse vegetation and diverse ecosystem, have such a widespread bioluminescence? Absolutely. In environments where light is limited, such as dense jungles or alien atmospheres with a thick cloud cover, bioluminescence could evolve as a survival mechanism for navigation, communication, or even predation. However, maintaining such intense bioluminescence across an entire ecosystem would require a lot of energy. A possible explanation could be a unique energy source in Pandora's atmosphere or soil that supports this phenomena. So while Pandora's glowing flora and fauna are exaggerated for cinematic appeal, they are not entirely outside the realm of possibility. Now let's explore one of the most iconic aspects of the Na'vi, their natural connection with nature through the queue on their head. This braid-like appendage allows them to bond with animals, plants, and even the secretary of souls. But could such a connection exist in real life? To answer that, let's delve into neuroscience. Our brains communicate through synapses where neurons exchange electrical and chemical signals. In the Na'vis, their Q acts as an external neural interface, allowing direct communication with other organisms' nervous systems. While no such neural ability exists on Earth, humans are developing similar technologies. Neural implants such as Elon Musk's Neuralink aim to connect human brains with computers, enabling direct brain-to-brain or brain-to-machine communication. In nature, symbiotic relationships hint at the possibility of such connections. Consider mycorrhizal fungi, which form networks with plant roots exchanging nutrients and chemical signals. Dubbed the Wood Wide Web, this system enables trees to share resources and even warn each other about the dangers. Could a biological neural interface evolve naturally? It would require organisms to have highly specialized nerve-like structures and a shared biochemical language. While not impossible, it's a stretch for now. Still, advancements in bioengineering might bring us closer to a world where humans can communicate with animals or even plants, though probably not through a glowing braid.
VFR from here on.
What's VFR?
Perhaps one of the most jaw-dropping features of Pandora is the Hallelujah Mountains, which float gracefully in mid-air. Is there any science basis for these soaring peaks? The explanation given in Avatar involves unobtainium, a fictional mineral with strong magnetic properties that interact with Pandora's powerful magnetic fields to create levitation. While plutonium is pure science, the concept of magnetic levitation is very real. On Earth, we use magnetic levitation or maglev technology for high-speed trains. These trains hover above tracks using strong magnetic fields, creating a superconductor or electromagnets, reducing friction and allowing incredible speeds. The key lies in the phenomena called diamagnetism, a property of certain materials that repel magnetic fields. If a material with extreme diamagnetic properties were abundant in nature, it could theoretically create a levitating effect. For Pandora's floating mountains to exist, we would need a planet with magnetic fields far stronger than Earth's. Secondly, mountains rich in a high diamagnetic substance like plutonium, and then lastly, stable conditions to keep the mountains suspended without external energy input. While such conditions are highly improbable, they are not entirely implausible. Some researchers have even suggested that levitating objects using superconductors could mimic the effects on a much smaller scale. But for now, floating mountains remain a marvel of cinematic imagination rather than a scientific reality. One of the most profound and philosophical aspects of Pandora is Eywa, the planet's deity and the neural network that connects all living beings. Through the trees of souls, the Navi can communicate with their ancestors and share memories. Could such a collective consciousness exist in real life? The concept has parallels with emerging ideas in neuroscience and technology. Neural networks in our own brains operate in a way that could be compared to Pandora's Eywa. Billions of neurons are interconnected, creating a web of communication that gives rise to thoughts, memories, and consciousness. Imagine scaling this concept to an entire ecosystem, a planetary brain where every living organism communicates to the collective intelligence. On Earth, scientists are studying how interconnected systems share information. For example, plants and fungi exchange chemical signals through mycorrhizal networks. And certain animals display collective decision-making, such as bee swarms or fish schools. These are early hints of how distributed intelligence can arise in nature. Technologically, humans are making strides toward creating artificial networks that mimic this idea. Cloud computing and the Internet of Things connect billions of devices, enabling them to share data seamlessly. If we could integrate biological and technological networks, the dream of a real-life Eywa might not be that far-fetched. While this raises ethical and practical challenges, it's a fascinating glimpse into what the future might hold. So how does Pandora's science hold up? The bioluminescence ecosystem finds strong parallels in Earth's natural world, and while the Navi's neural connections pushes the boundaries of biology, it's not entirely beyond the realm of future possibilities. The floating mountains, while scientifically improbable, showcase the limitless creativity of science fiction, and the idea of a collective consciousness embodied by Eywa inspires us to rethink how interconnected life on Earth truly is. But more than the science, Avatar inspires us to dream. It invites us to imagine a world where humanity coexists harmoniously with nature and challenges us to explore the possibilities of our own planet and beyond. But what's your favorite science concept from Avatar? Let us know in the comment section below. Until next time, stay enthusiastic.